Welcome to the presentation of the Texas Wildlife Research Boat Project. This is Assignment 6 Project Network, developed by Group 4 NexGen engineers. My name is Victoria Nunez, and I am the project manager for this assignment. Along with me are Alex, Piero, Brianna, Tala, and Sai. Let's get started with a quick overview of what we will be covering today. Today's agenda will begin with an executive summary where we'll give a quick overview of the project. Next, we will dive into the task breakdown and dependencies, explaining how the tasks for our project were defined and how they connect with each other. We will then present the PERT analysis overview, where we used a mathematical technique to calculate task durations. Following that, we'll show you the Slack table and explain how it helps us to identify tasks with flexible timelines. Finally, we'll conclude with our network diagram and critical path and discuss how it impacts the project's success. And then our conclusion. Let's now dive into the executive summary of our project. We are going to break down the key points of the Texas Wildlife Research Boat Project. First, the project overview, which outlines that this project aims to create a specialized research boat for wildlife conservation and marine biology research along the Texas coast. Our objective is to optimize scheduling by creating a detailed project network. This network will ensure the project is completed in a timely and efficient manner, balancing all resource allocation. Next, the key focus of our analysis is the PERT analysis, which will help us eliminate task durations and identify critical tasks that will directly affect the project's timeline. And finally, the outcome of the process is to determine the critical path. The critical path will highlight tasks that directly impact the project's completion, while the Slack table will identify flexible tasks that allow us to optimize the overall project schedule. Now we will go over the task breakdown and dependencies. The tasks for the Texas Wildlife Research Boat were developed based on our work breakdown structure and refined using the Gantt chart. Each task was assigned an optimistic, likely, and pessimistic duration to account for potential uncertainties in scheduling. To simplify the network diagram, we grouped sequential work packages with single predecessors and successors into sets of activities instead of listing individual tasks separately. This ensured a more manageable and readable representation of the project flow. Dependencies between tasks were established by analyzing the logical sequence of work. For example, before the deck could be fabricated, the hull needed to be completed. Similarly, ordering electrical system materials had to occur before setting up the system. This structured approach allowed us to visualize which tasks were dependent on previous completions and how they flowed into the overall project timeline. Also, each team member worked on the same activities assigned in previous assignments, ensuring continuity. Their responsibilities carried over as we transitioned from the Gantt chart to the network diagram, maintaining a consistent division of work. This table provides a detailed breakdown of the project tasks, showing how each activity connects to the next through defined dependencies. Each task was assigned an optimistic, likely, and pessimistic duration to estimate the expected time needed for completion. These values help us analyze task variability and assess potential delays. By structuring our activities this way, we ensure the logical flow of work from material orders to system installations. This setup was crucial for accurately mapping the project network and determining the critical path for the project completion. Now we're moving on to the PERT analysis overview. So we used the PERT technique to estimate task durations by factoring in uncertainty. To calculate the expected time for each task, we used the formula TE, which was the optimistic plus 4 times likely plus pessimistic divided by 6. In Excel, we implemented this formula using the round function to ensure better accuracy, and we used the same technique for the VAR formula as well. We also used round function in Excel. By using Excel, we automated these calculations, improving efficiency and reducing errors while refining our project schedule. Now for the slack table. We calculated slack for each activity to determine how much flexibility exists without delaying the overall project. Slack was calculated by comparing the LS and ES times as well as the LF and EF times. So over here, as you can see in the Excel, we have all of that, all of the values there. We also rounded the values to the nearest whole number to simplify the results. And the activities on the critical path have 0 slack, meaning any delay in these tasks would extend the project timeline. Tasks with non-zero slack provide some flexibility, offering opportunities to adjust the schedule if needed. Now on to our network diagram. The network diagram visually represents the sequence of tasks and their dependencies. By organizing the activities in the proper order, we can track how each task depends on the completion of others before it can begin. This layout helped identify the critical path as well. And as you can see, the diagram was kept within 40 to 60 nodes to maintain clarity and ensure manageability. Each node included a detailed value calculations such as the TE and the VAR and the slack values as well as the ES, LS, EF, and LFs. Now take a look at the critical path here. The path represents the longest sequence of tasks that directly determines the overall project timeline. Notice that the tasks along this path have 0 slack, and you can see as it's represented in the Excel as well, highlighted here. The critical path is crucial because it helps us identify which tasks require the most attention. So in conclusion, we identified the key tasks, mapped dependencies, and created a structured project timeline. The critical path was calculated, showing the project will take about 11 to 12 days, and the PERT analysis helped estimate task durations and calculate slack for non-critical tasks. And by focusing on the critical path, we ensured an optimized timeline for the project completion. That concludes the presentation. Thank you for your attention, and we do appreciate your time. Thank you.